For our final live coding example, I'm going to show you how we can use inheritance and overriding to create a very simplistic bag system for a role-playing game. In a role-playing game, there are usually thousands of items in the game world, and we need to be able to treat all these items the same by being able to place them into bags. Additionally, though, bags usually have different sizes and different types of items that they'll allow in them. So I'm going to show you how to override the methods that we create to put in a bag such that we can add like weight limits. So to get started, we're going to start on the item side. I'm going to right click, I'm going to add a new folder, I'm going to call it items, and I'm going to put all my item classes in here. In a real application, I would probably have many subfolders. I'd have weapon items and armor items and all different types, and there'd be a lot of inheritance going on. But for this, we're just going to keep it simple. So let's start with a base class for items. I'm going to add a class. I'm going to call it item. And I'm going to put two properties on this. The first one is going to be a string that just has the name of the item. And the second one is going to be an integer that represents the weight of an item. And that's pretty good. Now let's add 2 or 3 different items to our world. Let's add a sword. Sword is going to implement item. And in the constructor of the sword, let's set the properties. Let's set the name equal to a wooden sword. A little throwback to Zelda. And the weight of this item will be 3. Let's also add another item. And let's call this one a potion. It will also derive from the item class. And in the constructor, let's set the properties. Name equals a healing potion. And the weight of this item is only 1. This is all well and good. The next thing we want to create is a bag. So let's right click up here. Let's add a new folder. Let's call this one containers. And let's write a class for bag. So let's add a class. We'll call this a bag. Now the first question is a bag an item? I think it is. So let's inherit from item. Now because item is in a different folder, that means it's in a different namespace. So when I step off this, it's going to underline it in red. It can't find it. If we control period, it's going to give us some options here. Would you like to add a using statement? Yes, I would. Now it knows where to find it. So when I create a bag, the first thing I want to do is I want to say how many slots are in the bag. How many items can this bag hold? So I'm going to make a constructor, and I'm going to lock it down such that we have to give it a number that tells it how many slots the bag can hold. We're going to set the name equal to a small brown bag. We're going to set the weight 2. And now I need to start keeping track of my inventory. So let's create some variables to keep track of this stuff. We're going to start with a protected integer, and we're going to call it capacity. And that's going to keep track of the size of the bag. I also need to keep track of how many slots we've used up in the bag. And let's call that the current index, because we're going to use an array to keep track of all our items. And then the last thing is let's create a protected array of items. And we'll call this the items in the bag. I made these protected because we may want to have different types of bags later. This is going to be the bag base class, which is going to take care of all the basic functionality that all bags will have, including adding and removing items and displaying the contents of the bag. So in our constructor, since we're passing in a capacity, let's go ahead and instantiate our item array. Items in bag is equal to a new array of items, the size of which will be the capacity that we pass in. Now we need to be able to add an item to the bag. Say public virtual void add item. We're going to pass in an item that is going to be our item to add. Okay? And the first thing we need to do is see if there's enough room for the item. So let's say if the current index is greater than or equal to the capacity console right line, the bag is full. Otherwise, let's go ahead and add it to the bag. So the items in the bag at the current index, we're going to set that element equal to the item that we passed in. And then we're going to increment the current index because we want the next item to go into the next slot. We can also remove an item. So let's write a method for that. I'm going to make this virtual. And this time we're going to return an item. We'll call this remove item. And we'll say that the item that we're going to return is equal to items in bag at the current index. So being a simple bag, we can only put things in order, and then we can only take them out in the same order. We're not going to do any fancy searching for a particular item or anything like that. Then we're going to set the items in the bag at the current index equal to null, because we're removing it, and we're going to decrement the current index. And then we're going to return our item. The last thing I want to do is be able to display the contents of our bag. So let's make one more virtual void. We're going to call this one display contents. And here we're going to loop our internal array, and we're going to display all the items in the bag. So here's the items in the bag. And this is a great use for each. Item in items in bag. Remember that we have null values in this array potentially. So we're going to say if the current element is not null, then we can go ahead and print it out. We're just going to write out the name of the item. Just like that. So now we have a pretty good bag. Let's test it out. So let's go over to our program main, and let's do a little bag test. We'll generate a method for this. And we'll say bag, add a using statement, my bag equals a new bag, and we're going to give it 3 slots. And then let's create a couple items. So let's say var item1 equals new sword. We're going to have to add our using statement for that. So control period, put the using statement up to the top. Var item2 equals new potion. Now let's say my bag add item, item 1, and my bag add item, item 2. And then let's display the contents. We'll put a console.readline up here so the app doesn't close. And let's see what happens. And it says the bag is full, items in bag. So what went wrong? Let's go take a look here. In our bag, it thinks that the current index is greater than or equal to the capacity. Well, I thought that I set the capacity to 3, but then looking at my constructor, I'm taking in the capacity, I'm initializing the array, but I'm not actually storing the capacity. So let's go ahead and fix that. And now let's run our code again. And we'll see now that the items in the bag renders correctly. So now this is a general purpose bag. It will take any item in it. It will have any capacity. Now let's say that I want to make a bag that's very small. Let's say it's like a sack. And one of the things about a sack is that it can only take really small items, like potions. But it should not allow larger items like swords. We're going to override our add item method such that it restricts it by weight. So let's right click our container, let's add a class, and let's call this one sack. And sack implements bag. Now what I can do, since in the bag class the add item is virtual, I'm going to say public override, and I can select add item. And by default it's going to call the base add item. The base code works perfectly fine. It's only going to allow me to add something if there's available capacity. But there's no restriction for weight. So let's do that in our override method. Let's say if the item to add weight is greater than 1, console.writeline, that item is too big for the bag. Sack, for the sack. Otherwise, go ahead and try to add it to the bag. Our logic in base add item is perfectly fine to keep using. Now let's go out and test this. We'll do a private static void sack test, and let's spin up a new sack. And let's give it 4 slots. Now one of the things that happens here is that the base class has a constructor that requires a parameter. The sack class, we did not add a constructor that requires a parameter. So you notice that the constructor did not come along in inheritance. That's an important point to notice. I wanted to show you that. So let's go back to the sack class and let's add a constructor that takes in a capacity. And here we're going to use the base keyword and pass along the capacity from the constructor. This is how we can chain constructors to get access to things. It's a very important thing to know when you're dealing with inheritance. Now we can see our code is fine. Let's try to add a sword to the sack. That's going to fail. And then let's try to add a potion, which due to its weight should succeed. So let's call sack add item, item 1, and sack add item, item 2. And then let's display the contents. Let's comment out the bag test. Let's run the sack test. And what we should see is that it should print a message that the sword is too big, but the potion should go in, and when we display contents, we should only see one item in our sack. And that's what we got. That item is too big for the sack. That was the sword. But the healing potion made it into the bag. So it all worked out pretty well. So you can see how we can use inheritance and polymorphism in tandem. It would be very easy for me to add many different types of containers in my world. It's now very easy for me to add hundreds or thousands of items. And as items got more specific, I could keep adding more properties to them and more base classes. For example, maybe sword should inherit from a class called weapon, which inherits from item. And weapon might add information about how much damage the sword does, or what the weapon condition of the sword is. At that point, I could add a container called a weapon rack, and check to see if whatever was being put in it derived from weapon. So you can mix and match these things and add restrictions and override things and make it infinitely expandable. But at the core level, the container's bag base class handles adding and removing items. All the other rules happen in the derived classes. So that core code gets shared everywhere. I only need to write it one time. That is the power of inheritance mixed with polymorphism. The last thing I'm going to do is clean up my removal code, because I think there's some problems with it. We should test it real quick. Let's go into the bag, and when I look at remove item, the first thing I realize is that I'm removing the item from the current index, but the actual item is one spot behind that. So when I remove an item, I need to remove from the current index -1. The other thing is if the current index happens to be 0, that means the bag is empty and there's nothing to remove. So let's just go ahead and say if the current index is equal to 0, console, write line, the bag is empty. Else, we can go ahead and do our removal logic and return the item. Now in this case, because the method has to be able to return something, it's going to give me a little red squiggly because this if statement does not return anything. Well, if the bag is empty, in this case we'll just return a null because there's nothing there. And that will satisfy the condition. You can always return null from a method like this that's based on a class. So let's go back to our program. Let's do a remove test. And for this we can just copy our bag. Let's add a third item. Then we'll display the contents. We'll take an item off the top. We'll print out that we removed the item. And then we'll display the contents again, just to prove that it happened. So let's give this a try. We'll comment out this method. We'll run the code. So when we run this code, you'll notice I got an index out of range exception. That always happens when you try to access an element that is outside the total range of the array. And looking at my code, at the line where it broke on, I see where I made my mistake. I put current index -1 here when I was grabbing an item to return, but I didn't do it on the next line where I set it to null. If I hover over my current index, you'll see that the current index is 3. Well, the capacity of the bag is also 3, which means the slots go from 0 to 2. Index 3 does not exist, so it got angry with me. So let's stop this. Let's put a -1 in here. Then we'll save it. Let's run it again. And this time, you see we have 3 items in the bag. We remove the wooden sword, and then we only have 2 items in the bag. So now it's working properly. So wrapping up this live coding session, the one thing I want to make you aware of is that when it comes to inheritance and designs like this, there is a lot of planning that goes into this process. And very rarely will developers just start from inheritance. Patterns tend to emerge. You start writing some code that works, and as you see patterns emerge, places where you start to duplicate your code, that's when we stop, really examine what's going on, and decide whether we should refactor something into inheritance. If you try to just start from inheritance, usually you're going to end up with a design that is too complicated, and that's never a good thing.